Hey guys, welcome to Section 5, Chapter 9 of the Geometry program. And this is actually going to be the first of two videos for this section. I just realized that we had a lot of examples I wanted to get through, and I didn't want to do a 30-minute video. So we're going to split it into two. All right, in this section, we're going to put kind of everything that we've learned this chapter together. And the first thing we're going to talk about is finding the area of a triangle that's not a right triangle, but given the conditions known as SAS. And you'll remember that from chapter 4, where we studied side, angle, side. And so here is a diagram for you. So if we have a triangle, and it does not have to be a right triangle, notice there's no right angle here, and we're given the sides B, C, and the included angle A, then we have a special formula that we can use to find the area of that triangle. And that is area equals 1/2 the two sides, the product of the two sides, times the sine of angle A. All right, this is really straightforward, so I'm just going to do one example for you. So if we have area equals 1/2 BC sine A, then in this example, again, we have this side, we have the included angle and a side. So I know that I can use this special formula, and we're just going to plug in. So B and C are the side lengths, and because this is multiplication, any order matters. So it doesn't matter which one you grab first. And then the sine of the angle measure. So just know that the value that's going to go in here, of course, is the included angle. And then all we have to do is multiply these through on our calculator, and I think usually round to the nearest tenth. So when you do that, you're going to get the area of this triangle is 24.0 meters squared. So I think for most of these problems, we're going to round to the nearest tenth, but it's pretty straightforward. Just plug it in and you should be good. All right. But the heart of this section lies with this, finding the area of regular polygons. So now we're going to get out of triangles specifically and move to regular polygons. Now remember that polygons are these closed shapes, and a regular polygon means that all the sides and all the angles are congruent. Now let's say all the sides and all the angles are the same. And that's important, particularly the fact that the sides are the same. And that's going to help us be able to solve this new formula. So our general formula for finding the area of regular polygons is area equals 1/2 P times A, where P is the perimeter of the polygon and A is the apothem. Now, we have mentioned that before, but let's just review what the apothem is. The apothem is the line from the center of the polygon to a side that forms a right angle. Okay? So it's from the center of the polygon to a side, and it forms a right angle. And that's important for us because that's going to help us construct a right triangle and then be able to use all of our fun new tools. Okay, so let's say you're given this triangle and you're given the radius of 6. Now again, a radius is from the center of a polygon to a vertex. Okay, we're going to actually be solving different types, given different types of information of the polygon, but the examples for this video are going to start with just the radii. So the radius is from the center to a vertex, and believe it or not, that is enough information for us to solve this. All right, so we need to find two things. We need to find the perimeter, and we need to find the apothem. All we have is the radius. But we're going to draw in the apothem by dropping down that line from the center to the side, forming the right angle. And now what we really need to go from here is this angle. And believe it or not, we have enough information to find that. So because this is a regular polygon, all of the central angles are the same. And remember, we could find central angles by taking 360 degrees divided by the number of sides. In this case, we only have 3 sides. And so our central angles are 120. So what does that look like? So I'm going to draw in a central angle here, and that means that this value is 120. And it means all of these are 120, and it means this guy is 120. But I don't need that entire central angle for my triangle. I actually just need half of it. So what's half of 120 is 60 degrees. Okay, now we're in something very familiar. We're in a 30, 60, 90 triangle. And we know a lot about that because we did a lot of work on those side ratios. So if you remember that the hypotenuse was twice the opposite the 30, and this was square root 3. So hopefully you're remembering this. And so without actually having to use our trigonometry, we can fill in the pieces of this triangle. All right, this is our apothem, and for the sake of SOHCAHTOA, I'm going to call this the opposite side, because everything is going to be in relationship to this 60-degree angle. All right, now I can find the apothem by knowing that this is a 30, 60, 90, and knowing that the hypotenuse is 6, and half of that, opposite the 30, has got to be 3. So the apothem is actually 3. And we know the opposite side because remember my relationship said take the short side and multiply it by the square root of 3. And that was going to give us the side opposite the 60-degree angle. So again, if you want to just see this triangle outside, this is 6, this is 30 degrees, this was 60. So this means this is 3 and this is 3 root 3. Remember, this is 1, 2, square root of 3. Okay, now we're almost ready to be able to use our area formula. We have found this part of the side. It's 3 root 3. In order for me to find the entire side length of this triangle, I simply have to multiply that times 2, right? I have 2 pieces of that. So that means each of the sides are going to be 6 root 3. And in order to find my perimeter, I simply add those 6 root 3's together, and I'm going to get 18 root 3. All right, now I'm ready to actually solve this. So the area equals 1/2 perimeter, which is 18 root 3, times the apothem, which is 3. And when you multiply that together, you're going to get 27 root 3 meters squared. Now, I would love for you to leave this in radical form if you're able to. Sometimes we're going to have to make approximations, and that's fine. But if you're using radicals, feel free to just simplify the radical and call it good. Don't feel like you have to change it into a decimal. However, in order to check your answers, you're probably going to have to convert that to a decimal to just make sure that you have the right answer. Okay, next one. Let's say we have a square, also with a radius here, but this time our radius is 10. First thing I'm going to do is drop down the apothem. And this is my opposite side. Now I have to find my central angle. That's always going to be 360 divided by the number of sides, which is 90. So here I see my central angle is 90 degrees. I want half of that for my triangle, which is going to put me in a 45 triangle, as it turns out. And we know something about those triangles, about the side ratios. Remember, in the 45, it's 1, 1, square root of 2. We're bringing all of it together. Okay, so in order for me to find actually both the opposite side and the apothem, all I have to do is take 10 and remember, divide it by the square root of 2. Well, we can't just divide by the square root of 2 and leave it there. We have to rationalize. And when we do that, we're going to get 10 root 2 divided by 2, which is 5 root 2. And since both angles are 45, both sides are also going to be the same, which is 5 root 2. So my apothem is 5 root 2. And now my half side here is 5 root 2, which means my entire side is going to be 10 root 2. And when I multiply 10 root 2 times 4, I get my perimeter, which is 40 root 2. And now we're able to plug into our formula. Area equals 1/2 perimeter, which is 40 root 2, times the apothem, which is 5 root 2. Again, when we multiply that all together and leave it in radical form, actually everything multiplies out here, we're going to get 200 meters squared. All right, I'm going to do one more example for you where we actually have to use our trig and not our side ratios. Let's say we're in an octagon. Now, in an octagon, my central angles are 360 divided by 8, which is 45. That's the central angle, and I need half of that, which means the angle I'm using is 22.5 degrees. And that's not something we have any side ratios for. So, okay, now in order to be able to solve for the opposite side in the apothem, we have to use our trig formulas. So you got to pull out SOHCAHTOA again, and everything is in reference to this central angle. So in order to find the opposite side, I'm going to need the sine. So the sine of 22.5 is the opposite over 8. So the opposite is going to be 8 times the sine of 22.5. And now this is an example where you're going to need an approximation. And I like to keep my approximations to 3 decimal places until the end. All right, so my opposite side is this 3.061. If I multiply that times 2, I'm going to get my side length, which is going to be 6.123. And if I put that all together for my perimeter, then I'm going to take 6.123 times 8, giving me 48.983. Okay, that's my side length. Now I need my apothem. So my apothem is going to use the cosine. So the cosine of 22.5 is the apothem, also the adjacent side, over 8. So the apothem is going to be 8 cosine 22.5. And that approximation is going to be 7.391. All right, now you have everything you need to put this together. Area equals 1/2 perimeter, which is 48.983 times the apothem, which is 7.391. And when I multiply that all together and round to the nearest tenth now, I'm going to get 181 meters squared. Okay, I know I rushed that really fast, but I wanted to make sure that we got through all 3 of those examples. So take your time, go back through, make sure that you understand step by step the way we did it. And then when you're ready, finish up your notes, read through the examples, and begin your assignment.